So once we go through this material, at the end of the session we'll be having I'll be showing a demonstration how this sorting actually works. Okay, now this is one of the basic problem and basic question which comes in C programming. What are the different types of sorting techniques available in C language? Okay, so what are the different sorting techniques in C language? So explain any one sorting technique with an example. Okay, so in your syllabus, okay, so normally in C programming we have five sorting techniques, five sorting algorithms. That is nothing but bubble sort, that is also called as exchange sort, selection sort, insertion sort, quick sort, and merge sort. Okay, so if I give a question in your end semester or your internal assessment, okay, write a sorting program using this particular technique, automatically you should use that particular technique only. Apart from that, you should not go elsewhere. Okay, but if the question is blind, give an example with a sorting algorithm in C programming, then you can choose whichever is favorite to you. Okay, but in your syllabus only one sorting algorithm is available. Okay, apart from that, I think no sorting algorithm is available. Okay, so for you, bubble sort will be in your syllabus. So we'll be discussing how bubble sort is being executed in C programming and what is the use. Okay, apart from bubble sort, I don't think you will be studying selection insertion, but apart from that you should have some knowledge. Okay, so bubble sort. So when you compare to the all five sorting algorithms, this is one of the most simplest and easiest way of sorting the values inside an array. Okay, so it is the simplest sorting technique, which is called as a exchange sort. Okay, so there are some standard procedures, so you should know. That is nothing but ground rules. Okay, how this works? First of all, you will be creating an array. Okay, so for example, I'll just demonstrate here. Okay, for example, I have created an array A of 5. Okay, so automatically what happens, 5 slots will be created in the memory. So these 5 slots have an index value 0, and this is 1, and this is 2, 3, and this is 4. So automatically, if I create an array like this, int A of 5, automatically a variable A will be creating 5 slots for the values to be entered. So that index value will be starting from the value 0, 1, 2, 3, and 4. Okay, now this is nothing but the index value. So inside the index value, you'll be writing the actual elements. That is nothing but the values what you're going to enter. Okay, it can be like 34 or 67 or some numbers. Okay, now imagine you're having an array like this: 34, 67, 928, 99, and 0. Now these values what you have entered, it's purely what to say, one by one you have entered. Okay, first you will be entering 34, automatically it will be stored in the index value 0, then 67, then 928, then 99, then 0. This is what you entered and this is what the array looks like. But once you enter this value inside the array, automatically you need to shuffle them. Okay, so you need to perform the sorting algorithm and you need to make them in a correct order. Okay, so after applying the techniques, okay, just I'll write after the sorting technique used, then automatically you should able to rearrange all the values what you have entered here. So automatically like 0, then we have 34, then we have 67, 99, then 928. Okay, now you have now I think you might have a clear picture. First of all, we'll be declaring an array A of 5. So 5 slots will be created with an index value of 0 to 4. Okay, so these are the values you will be entering from the first, second, third, fourth, and fifth. Now, after applying the sorting technique, it can be a bubble sort, it can be an insertion sort, merge sort, whatever. So the final array should be looking like this. Okay, so the final output should be rearranged like this. Okay, so how it is being rearranged? Okay, so that is the important thing you should able to know. So in this session, you will be studying bubble sort, and I believe that this is the only sort will be uh, available for your syllabus. Okay, so first of all, you need to know the ground rules. Okay, compare the first element with the remaining elements. This is the most important rule of the bubble sort. Okay, so imagine you're taking 34. Okay, so you need to compare the first element, that is nothing but 34, with the remaining elements 67, 928, 99, and 0. So you will be keep on comparing the elements in the list, and you will be performing something called swap. Okay, there is something called swap. Okay, for example, consider this 34 and 67. An important part is that in the coding part, you should be able to give who's greater and who's lesser. For example, if 34 is less than 67, then you don't need to exchange this particular value. Okay, so automatically 34 will be sitting here. Okay, it won't swap with the 67 because 67 is greater number. But when you are swapping, so it will fail here, here, and here, because 34 is a value which is far less than the comparing to these three values, but it will compare with this particular value 0. So 0 is obviously less than 34. Automatically what happens, 0 will be replaced here and 34 will be replaced here. Okay, so 0 will be replaced here. I'll just write like this: 0, 67, 928, 99, then 34. Okay, so this is nothing but the first iteration. Okay, so this is nothing but the first iteration. Okay, so the first rule of bubble sort is that compare the first element with the remaining elements in the list. If you find that 34 is greater than, or is there any value which is less than or equal to 34, automatically that values will be exchanged. Okay, then the second rule of this bubble sort is that you should able to keep on repeating until all the elements are getting sorted. Okay, now consider this example: 30, 50, 40, 10, and 20. Okay, so an array of 5 is created. Okay, so an array is created with the size of 5. So 5 elements are being entered: 30, 50, 40, 10, and 20. Okay, now inside the program it will be like this. So as you know, 5 slots in the sense, it will start from 0 to 4. Okay, and inside the array the values will be sitting like this: 30, 50, 40, 10, and 20. Okay, now you need to perform the first iteration, that is nothing but the first phase. Okay, so take the first element and you need to compare with the remaining elements inside the array. So as you can able to see, a strike mark here. Okay, so 30 will be compared with 50. Obviously it's less, so it won't be swapped. Then it will compare with 40, it won't be swapped, but there is a value 10. So 10 is less than 30. Automatically what happens is that these two numbers will be swapped. So in the iteration, you can be able to see the statements. This is nothing but A of 0. Okay, A of 0 is nothing but the index value. So A of 0 is 30, A of 1 is 50, 2 is 40, 3 is 30, then 4 is 20. Okay, so you can able to see a condition here. If A of 0 is greater than A of 1, so you can able to compare here. Whether 30 is greater than 50? No. Automatically, it will return a false statement and it will say no exchange. Okay, so no need to perform the swap operation. And what you do is that A of 0 will compare with the A of 2 here. That is nothing but 40. Then again, it will return a false message because 30 is less than 40. But in the third point, you can able to see A of 0 is greater than A of 3. So obviously, this thing should be swapped. But before swapping, it will cross verify the full array. Okay, so even though 10 is in the middle, it won't swap that much easily. Okay, it will go for another value inside the array. For example, instead of 20 here, if there is 5, or automatically this 5 will be swapped. Okay, so inside the array, it will be keep on searching. It will find a suitable comparator to swap, but it won't swap that much easy until it reaches the entire array value. Okay, now this is for 5, array of 5. For example, if I have created an array of 50 size, so imagine the first element and the fifth element should be swapped, but it won't swap that much easy. That first element will be comparing all the 50 values, then only the fifth value will be swapped with the first value. Okay, so this is a disadvantage for this particular technique. Even though there is a small value inside the array, which can be swapped easily. Okay, at you can able to see at the third line itself, you can able to perform the exchange. Okay, but the disadvantage is that even though there is a suitable comparator to swap, it won't swap that much easy. It will be go through all the array elements, all the remaining values inside the array. Then only it will perform the swap operation. Okay, so whatever technique you are learning, there is always a advantage as well as a disadvantage. Okay, so in the first phase, you can able to see 30 and 10. Okay, but it won't swap until it reaches all the values inside the array. Okay, now we can able to see that 10 is far more less than 20. So automatically these two will be swapped. Now, once the lowest value has been swapped, you can able to see 10 has been put here. Now 30 has been put here. Now, the next rule is nothing but it will go for the second value. Now you will be comparing this A of 1 with the remaining elements inside the array. Okay, you need to repeat the same process again and again. Okay, so now 50 will be comparing with 40. It's greater than true. 50 is greater than 30. It's true. 50 is greater than 20. So automatically you can able to see that A of 1 is greater than these conditions. So automatically what happens? First of all, you need to find which place should it replace. Okay, so like this it will be keep on going. Now in the third phase you can able to see now 50 is has been exchanged here. Okay, now again, now A of 2 will be comparing with A of 3. Okay, now it will be keep on comparing. At one particular point 40 and 50 will be exchanged. Okay, so in the next part you can able to see 40 and 50 are exchanged, and one particular point these two will be compared, and finally these two will be exchanged inside the array. So the final output will be 10, 20, 30, 40, 50. Okay, so first of all, whenever you're studying a new algorithm, a new technique, there are some standard procedures. So if you know that procedure correctly, automatically you can able to understand and you can able to do the coding part. Okay, so the ground rule is nothing but you need to compare the first element with the remaining element in the list, and you need to perform the swap operation. Okay, once the first value has been assigned in the appropriate position, you go for the second value. Okay, so in this example you can able to see in this example you can able to see 34 is the first element. It will be keep on comparing. Okay, at one particular point, it finds the lowest value. Automatically, this array will be exchanged. 0 and 34 will be exchanged. Okay, now since 0 is the very lowest number in the array, automatically by default you can go for the next number. Now 67. Now 67, no need to go for left comparison, only right comparison. Okay, now 67 is less than 928. Okay, it's true. Okay, now 34. I mean, sorry, 99. Then 34. At one particular point, 0, 34, 928, 99, then 67. Okay, now similarly, once these two values are the lowest values in the array, it will be keep on repeating like this. Now 928. Now 928 is the biggest number here. Okay. Now it will compare with 99. Obviously, this is the big. This is the lowest number, and it will find not only swap with here. It will find the lowest value here, 67. Then obviously, what happens? 67 will be coming here, 99 will be here, then 928 will be here. Okay. Now the first three numbers are the same. So obviously 0, 34, 67. Now 99 and 928 will be compared. So obviously 99 is the less number. So 99 and 928 will be the answer. So this is the actual array what you have entered. Okay. And this is the final output. Okay. So in between, you can able to see there are three iterations. At first iteration, 34 will be exchanged with 0. At the second iteration, you can able to see 67 is being replaced with 34, then 928 with 67, then so on. Okay, so based upon the values which you are given, and based upon the values you need to swap, the final output should be in a ascending to descending order. Okay, so how do you write the coding part? Okay, just like that, it won't get sorted. There are certain rules in writing the coding. Okay, I'll upload this document in the Google Classroom for your reference. So you can cross verify it. So this is the procedure for bubble sort. Okay, so this is the procedure for writing a bubble sort coding inside the C program. Okay, so you can able to see, first of all, the for loop for I is equal to 0, I less than n minus 1. Okay, I less than n minus 1. That is nothing but I will be the leftmost value. That is nothing but the first value. And j will be the comparing. It will be keep on comparing with the next values inside the array. Okay. Now here there will be a small if condition. If a of I, that is nothing but the first element, is greater or is greater than a of j, there is something called swapping technique. This is nothing but the swapping technique. So you will introduce a small variable, a temporary variable. In that temporary variable, okay, t is equal to a of I. So what is the a of I value here? There will be some value. So automatically that value will be stored inside t. Okay. Now you can able to see the second line. A of j. What is the a of j value? Again, there will be some value. That value will be assigned to a of I. Now this t, right? This t will be assigned to a of j. Okay. So this is how the swapping program works for in C program. Okay. Now we'll do a small example. I'll just open the terminal. Okay, as usual, uh, C program to perform bubble sort. So first of all, as usual, you'll be including the headers and a main function. Okay. Now, since you're dealing with arrays, automatically you can create an array. So let's say array of 10. Okay. So 10 slots will be created from 0 to 9. Okay. You're going to get, you'll be asking a question to the user. How many elements you're going to enter inside the array? Okay. So enter the number of, just say, enter the number of elements. So how many numbers you're going to enter? So that is what you're going to ask for the user, and automatically this particular value will be stored in a variable which is called n. Okay. So automatically you can able to declare all the necessary variables. Once you got the values, enter the number of values. Then again you're going to ask the user, enter the values for the array. So you will be performing a, you will be repeatedly entering all the values. So all the values will be stored inside a single variable. Okay. So for that we will be using a for loop. So here for I is equal to 0, I less than n, then I plus plus, I plus plus. Here, just write scanf. Whatever values that you are entering inside the array, again it will be stored in the array. Okay. So ampersand a of I. Okay. So here you have created an array of size 10. Array size 10. So automatically 10 slots will be created. Okay. From 0 to 9. Now these are the necessary variables. The necessary variables you're going to use for this particular program. Okay. So for that, first of all, you will be asking the user how many values you are going to enter. For example, 5 or 6. So depending upon that, the array size will be allocated. So you have created 10 slots. For example, if I'm going to enter 6 slots, automatically the remaining 4 slots will be, it won't be used inside your memory bank. The first 6 slots will be used. So you're asking the user a question, how many number of values you're going to enter? 5 or 6 or 10 something. Okay. So whatever values the user enters, automatically it will be stored in a variable which is nothing but n. Now again, now you're going to ask the same question. Enter the values inside the array. Okay, enter the values for the array or inside the array. Okay, now you will be entering all the 5 or 6 values. So for that, instead of creating one by one, you put a simple for loop. Okay, so we know the value of n, right? For example, 6 means from 0, 1, 2, 3, 4 and 5. So I should be less than 5. Okay, so automatically I should be less than 6. So automatically all the values will be stored in the single variable, which is nothing but I, and it will be stored in the a of I. Okay, now you need to use the bubble sort concept. Okay. Now comes the bubble sort concept. So what do you do is that this for loop is for storing the data. Now you're going to read the data from the for loop and you're going to perform the swapping operation. Okay. So for that, you might have saw the nested for loop procedure, which I showed you in the Word. So same concept, you just copy paste it in your Word file. Okay. So for I equal to 0, I should be less than n minus 1, then I plus plus. Okay. Now you need to open the braces. Again, now you're going for this is the first value. From the first value, going to compare all the remaining values. So for comparing the remaining values, you will be using another for loop, that is for j. So for j equal to I plus 1. Okay, that is nothing but the second element of the array. For example, if I is 0, that is nothing but the first slot. If j is I plus 1 means that is nothing but the second slot inside the array. Okay. Now, j should be less than n. Again, we know the array size. Then finally, a plus plus. Now, inside this particular nested loop, you will be putting a small condition that is nothing but if a of I is greater than a of j, then automatically, okay, then automatically you can able to perform a swap operation. Okay, so this is nothing but performing swap operation. Inside here, you will be including a temporary variable which is called we can write like a variable temp. Okay, this is nothing but a temporary variable. So inside here, the first value, that is nothing but a of I. Whatever a of I value is, it will be stored in this particular temporary variable. Okay. Now again, a of I is equal to a of j. And finally, a of j you need to include this temp here. So we are using I variable, j variable, then finally temp. So once this nested for loop gets over, you need to print it. Okay, you need to print the sorted array. So for that, you just write like this. After bubble sort, the elements, sorry, values are less than I plus plus. Now for printing, you'll be using this particular for loop. In the So this is the actual program for bubble sort. Okay. So first of all, you need to include the headers, the main function, a variable, an array with a specific size. Based upon the size, the slots will be created inside the memory, and you need to declare all the necessary variables. Okay. Then finally, you will be asking the user how many values you are going to enter inside the array. Okay. So 5 or 10 or 15, 20 values. So how many values you're going to enter? So you'll be asking a question to the user. Now, based on that particular value, what he has given, that particular value will be stored in a variable which is called n. Okay. Now, again, you'll be raising a question, enter the values inside the array for the array. Okay. So if I give 10, all the 10 values will be entered either in a sorted manner or in an unsorted manner. Okay, so I'll just randomly enter all the array values. Okay, for storing the array, or instead of creating 10 different variables or 10 different, a of 0, a of 1, 10 scanf, you can just use a simple for loop. Okay, so for I equal to 0, I less than n. So n is nothing but the number of elements you're going to enter inside the array. So that you'll be getting it previously from the user. Then I plus plus. Okay, so you'll be performing a small for loop operation, and you'll be storing all the 10 values inside this particular array, which is nothing but a of I. Okay, now we'll be using the bubble sort concept. So this for loop, you can able to see it is for storing this particular data. Okay, now you're going for the bubble sort concept. So the bubble sort concept, again, it's a nested for loop. Okay, so you can able to see for the I is nothing but the first element. Okay, the first element, and j is nothing but the remaining elements inside the array. Okay, if the first element is greater than the value which is situated inside the array, you need to perform something called swap operation. Okay, so for that, you will be creating a temporary variable. Okay, so temporary variable will be created. Whatever value which is in a of I, that is nothing but the first element, will be stored in the temporary variable. Okay, now a of I, that particular slot is empty. So the destination, that value will be stored in a of I. That is nothing but if it is in the fifth place, now it will be in the first place. And what value stored in the temporary value, now it will be stored in a of I. Okay, then finally you will be printing the sorted array. Okay, so for printing, reading, you can able to see a simple for loop is enough. So we will run this program. Okay, come and say. Okay, so now you can able to see it's asking me the number of values, but I have created an array size of 10, so I can able to enter all the 10 values. But if I want to enter only 5, I'll just press 5. So now the array size will be of 5 slots. Now I need to enter all the values manually. So for example, if I'm entering the lowest value, not the lowest value, the highest value, say 9. Okay. Then I'll be entering 3, then 8, then 152, then we have something called 0. Okay, 0. So you can able to see the first value is 9. Now 9 is greater than 3. Okay, so it can easily swap. So 3 can come here and 9 can come here. But that is not the original concept of swapping. So if there is a compatible value to be swapped, it won't easily swap until it reaches the full array list. So at the last, you can able to see there is a value 0, which is very, very smaller comparing to all. So automatically this 9 won't swap with 3. It will automatically, by default, it will be coming here. So these are the number of iterations. At one particular point, you can able to see all the sorted array in a ascending to descending order. Okay, so it got stuck. I'll enter it again. Five. Values 9, 3, 8, 1, 5, 2. Then we have 0. So you can able to see what you have entered here: 9, 3, 8, 152, 0. So once you have entered, the swapping operation, the bubble sort concept is used, and this is the final output of the bubble sort. So after bubble sort, the values are 0, 3, 8, 9, 52. Okay, just like that, it won't be shifting easy. So there are several number of iterations which is running behind, and based upon that only the final sorted value is displayed among.